And if you want to graph any one of them, I'll pick first this example, graph. We'll tell you what the A does, but let's say I give you this question, graph y equals sine of x. And probably the easiest thing is to take and make a table, pick some values for x, and we normally when we graph in radian, but I want to do it in degrees because you and I kind of understand like degrees more than radian for now. But once I finish with that, I'll switch it back to radian, show you what the graph will look like. So this is x, and this is sine of x. I'm going to pick values for x and see what the graph looks like. So maybe I'll use a 0 degree. And if you have a calculator, take your calculator out, find what is sine of 0. Just make sure you're in degree mode. Well, sine of 0 should be 0. Just hit 0 and sine, and it should tell you the answer is 0. If you're not sure how to use your calculator, let me know. I'm decent at TIs. The other ones I might struggle. 30 degrees. What's the sine of 30? Do you get a 0.5? Good. Let's try the 60. What's the sine of 60? Does it say 0.87 or 66? Yep. I just rounded to 0.87. 90 degrees. The sine is 1. I'm going by 30 degrees. 120. The sine is 0.87. 0.866 rounded to 0.87. 150. That's 0.5 again. 180. That's a 0. 210. That's a negative 0.5. 240. 30 more. 240. That's a negative 0.86. 270. That's a negative 1. 300. That's negative 0.86. 330. 360. Negative 0.5. 360. 0 again. I'm out of space, running out of space. But you can keep going. You can pick negative and positive values. What you're going to find out when you graph the sine of x, the graph of sine of x, if you graph it, it looks something like this. That's what it looks like. That's the 360. This is the 180. This is the 90. This is the 270, negative 1. So it goes as high as what? What is the biggest y value that you see here? 1. So the maximum height for it is 1, and the lowest point for that is what? Minus 1. And it doesn't stop here. There's just one cycle of it. If I pick another value like 390, guess what the value is going to be? You're going to have another shape start to look like this. And if I pick negative value, it's going to go like this. So I'm showing you only one cycle of sine of x. This is sine of x. Always has that shape. It takes 360 degrees to make it a full circle. 360 degrees in radian, that's 2 pi. In case you forgot, when you measure your angle, and I'll take you back quickly in a second here. Do I have a unit circle? Maybe I can have one here. Tech Math 1, hopefully, your teacher showed you something like this. That's a unit circle. When you measure the angle, if you measure them this way, that's a positive angle. And if you go this way, that's a negative angle. Remember that one? So notice, I'm giving you the values in degrees and radian. This is the 90 degrees. See it? Which is equal to what? Pi over 2 in radian. This is the 180 degrees, which is what? Pi. The 270, 3 pi over 2. 360, when you complete full cycle, that's actually 2 pi. So when you go from here, come back to the same spot, you travel 360 degrees, which is 2 pi. If you're into snowboarding, or what is it?
Skateboarding?
The bicycle one, BMX. Is it BMX? When they do 2 turns, what do they call that? 720. Why 720? Because each turn is what? 360 degrees. You start the jump, they do 1 turn, that's 360, another turn, that's 360, and they land. That's a 720. If you do 2.5 turns, you go, that's 360 plus 360. Half a turn is what? 180. Right? So what's 360 plus 360? 720 plus 180. You add the math, and that's what the turn or the jump they did there. That's for BMX bicycles, for snowboarding, skateboarding. They always talk about, oh, he's going to try 360 at 1080. Well, what's a 1080? 360s, when you do 2.5 turns, we said what? 360 plus 360. 360 plus 360, that's 720. And if you add half a turn to it, that's 180. You did 900. What happens if you do 3 turns? What's 3 times 360? That's what you just did. When somebody just did a 1080, that means spun around 3 times before he or she landed. You know. In figure skating, you see these skaters, they jump and they spin and land. They go and did a quadruple, a quad. A quad means what? 4 turns. So if we use the same lingo as like degrees, that'll be 4 times 360. What they just did, if they did a quad, is actually 1440. They spun around 4 times. 4 times 360, that's 1440 degrees. So angles can be measured positive if you travel counterclockwise, negative if you travel which way? Clockwise. So if you go in this way, that's a negative angle. So this is really, notice how this is plus 30. Then if you go this way, that's a negative 30. If you go up to this line, that's plus 45. If you come this way, that's a negative 45. If you go this way, that's plus 90. If you come down this way, that's a negative 90. If you go this way, that's plus 80, negative 80. So angles can be measured positive or negative. Depends which direction you're going. But each one of these is 90 degrees. If you look at your calculator there, or when we switch mode, notice I go to mode on my calculator, I have radian in degrees. See that? Can you see it on your screen? Radian in degrees. We measure angle either radian or degrees. And I got to be in the right mode. If you have a small one of those cheaper calculators, there's a third scale. It's called gradient. You want to see that? G-R-A-D? Gradient. And what that is, somebody came up with the idea, instead of having 90 for each one, let's use a different scale where each one of these is 100. So 100, 200, 300, 400. But nobody cared for that. Nobody really used it, but it's still on the calculator as a gradient. So if you have one of those like smaller, older calculators, you might see a gradient on it. But nobody uses that scale. Like it matches the metric system. 100, 100, 100, 100. That's the reason they want to switch like to 100 tens, multiple of tens all the time. But that's what the sine function looks like. If we can, and if I try to make a table for the cosine, will look a little bit different. So if I graph the sine versus the cosine on the same page, this is what my function will look like. I'll do them separate. I'll do the sine here. On the top, I'm going to do the sine. On the bottom, I'll do the cosine. So this is sine of x and this is the cosine of x. Again, if I just show you one cycle, one shape, because it repeats itself, looks like this. And we said it takes how many degrees to complete a full cycle? 360. We're going to write them in radian. 360 is equivalent to what? 2 pi. So this is 2 pi, which is 360, right? For now I write both values so you get to see them. We said this is half of that number. What's half 360? 180. And radian, that's what? There's my unit circle. What's 180? That's pi. By the way, you can just go to Google, write unit circle, and you'll find hundreds of these. You should print one, have it handy with you. We use them all the time. So just go any browser, it doesn't have to be Google, any browser, just write unit circle. That's what it's called, right on the board. That's what's called the unit circle. Nope. And once it shows up, there's some in color, some not in color. So you choose which one you want, some bigger than others, some smaller, some bigger. But write in a circle, print one of them, have it handy with you. We use them constantly. You need them for the test too. You get to use them on the test. So print one of them. Now, this is, we said the 90 degrees, right? What's 90 degrees? Pi over 2, right? And this one is what? We said that's a 270, which is 3 pi over 2. So probably after this slide, I will use radian. I just want you to see 2 pi. This is half of this. This one is half of this. This is halfway between this and that. Between pi and 2 pi. What's halfway between 1 and 2? 1.5, right? That's why 3/2 pi is 1.5. So what's the cosine looks like? It looks very similar to this, except, let me extend these lines. Where they cross, I just want to make sure we highlight these lines. The height here, we said the maximum height is 1. The lowest value is what? -1. If you take this sine function and you move it, drag it to the left till this point lands right here, what would you have? You will have the cosine. There's the 1. So this piece is going to be the y-axis. So by the time you go 90 degrees, it's going to hit this. It's going to look like this. Then it's going to go like this. And back to this. This is a -1. And again, this is the 2 pi. This is pi. This is 3 pi over 2. This is pi over 2. So remember, this one repeats itself. It doesn't stop. I'm just showing you one cycle. That's why that piece there. Notice if I extend that. So what we're saying, basically move the y-axis right there. And if you put it right there, isn't that what the picture you have there? I call this the Karate Kid. Remember him when he had his hands up in the air, trying to kick there? It starts high, it goes down, then it goes back up high. Danielson. Huh? The Karate Kid. So you'll hear me say the Karate Kid. That's the cosine. So if you memorize these two shapes, if somehow we can put these in memory, what the sine cosine looks like, we're going to show you what will happen if that number in the front is not a 1. I'm saying, what about if that number is not a 1? What about if it's a 2 or a half or a -5? What will happen to that graph? What will it look like?
Larger.
Yep, it could be larger, it could be smaller. It's called scalar. Either going to stretch it or you're going to compress it. If the value is more than 1, what's going to happen? You're going to stretch it. If it's less than 1, the value is going to be what? Compressed, shrunk. So let's take some examples and see what will happen. But remember these two pictures. So I'll mix and match and see what the graph might look like. So let's say I want a graph I'll take some examples here. I don't know. I can make 10,000 of them. I'll just make my own. Graph y equals 3 sine x. I'm going to put the basic sine function. Again, the basic sine function looks like this. This is the 2 pi. This is pi. If you keep writing them, by the time you leave this room, you'll know them. Pi over 2 and 3 pi over 2. The height for the basic sine function is 1. The low is what? -1. So this is sine of x. This is not what I'm graphing. I want to graph 3 times that. Well, if you take them point by point, just to show you, what is the value of the sine x here at this point? 0. So what's 3 times 0? Still 0. Right here, what is sine of x equal to? 1. What's 3 times 1? 3. Right here, what is sine of x equal to? 0. What's 3 times 0? 0. Right here, sine of x is -1. What is 3 times a -1? -3. Right here, sine of x is 0. What's 3 times 0? So my graph will look like this. When as high as what? 3. As low as what? -3. If I show you these functions on my calculator on top of each other, you will see exactly what I'm talking about here. Let me change my window just to show you the first 2 pi. So I'm going to go x minimum 0, and to go to 2 pi, 2, where's pi? Here we go, 2 pi. Can you see that? And let me make the y value minimum, I don't know, -3, and I'll go to 3. Let me write the first one. I'm going to write sine of x. The one thing I forgot to do is what? I forgot something. The next one is what? I'm going to graph 3 times sine of x. The one thing I forgot to do, I'm in, I think, degree mode. Let me check my mode first. Yes, I got to change it to radian. I'm graphing radian, right? So I'm in radian now. And now let me ask them to graph. This is sine of x, the first one that you see. And after that, I see 3 sine of x. Is that what we graphed? Yep. So the number in the front is given the letter A for a reason. Why they're called A? Amplitude, exactly. So the word amplitude, when we ask you what is the amplitude of the function, the amplitude is equal to the absolute value of A. Not A, the absolute value of that. And that is how high would it go? It will go to 1. So that's the reason why we use the letter A, amplitude. So when the number is 3, we're going to stretch that. It's going to go as high as 3. Okay, what about if that number is actually less than? Less than 1. Let's say I want to graph y equals 1/2 cosine of x. Here's cosine of x. I'll start with the basic function. It's the Karate Kid. Again, I'm only showing you one cycle. It keeps going. This is the 1, this is the negative 1. This is the 2 pi here. This is what? Pi. Pi over 2. 3 pi over 2. This is cosine x. So what is 1/2 that? Where is it going to start? 0.5. And how low is it going to go? Negative 0.5. And this is 1/2 cosine of x. Notice here we have what? Compression. It's like somebody squeezed it in, compressed it. The other one stretching is called. So when the value in the front is more than 1, we have stretching. When it's less than 1, we have compression. Let's try a couple more examples. Graph y equals negative sine of x. The negative is really negative what? Negative 1. Yeah, it's negative 1 times sine of x. We just don't put the 1. So again, let me start with the sine of x. Again, here's the sine of x. Two pi over 2, negative pi over 2. This is sine of x. Maybe I should do all mine in red.
3 pi over 2.
3, oh, what did I write? Pi over 2. It's, by the way, correct. What I wrote there is negative pi over 2 is still correct. It is the same as 3 pi over 2. Watch this. If you travel in this way, this is what? 3 pi over 2. But if you travel in this way, that's what? Nope. It's what? Negative that number. So it is negative pi over 2, but we don't like to number them that way. So 3 pi over 2 is the same as negative pi over 2. Going that distance from here to there, whatever that number, but it's coming down, so it's a negative of that number. So now, what is the minus 1 going to do? What's the minus sign?
Mirror image of the...
Exactly, it's going to flip it. So notice, when the sign is 0, what's negative 1 times 0? 0. Here the sign is what? 1. So what's negative 1 times 1? Negative 1. Here it's 0. What's negative 1 times 0? Here is negative 1. What's negative 1 times 1? Here is 0 times a negative 1, 0. So the graph, the minus sign, does this. Flips the graph. That's called reflection. This is negative sine of x. The positive becomes negative, the negative becomes positive. That's all it does. I'll do one more, then I'm done with this section and this video. Let's graph y equals negative 3 cosine x. Negative 3. Let me start with the cosine. So cosine of x looks like this. This is 1 and this is what? Negative 1, 2 pi, pi over 2, 3 pi over 2. So this is the basic cosine function. If I didn't have the minus, the 3 would be what? It's going to go as high as 3, right? It has the same shape, but the height is 3. But the minus sign is going to do what? It's going to flip it. So the graph should be, the graph should look like this. It's enlarged by a factor of 3, but also flipped. This is the negative 3, and that's the plus 3. Negative 3 cosine x. So it goes as high as 3 units, but also at the same time, you make the plus minus and the minus plus because of that negative sign in the front. And that's the end of section 10.1.